Welcome. Today we're going to be discussing what is the source of the wealth of nations. This is not the first time this question gets asked. It's the question that got economics started back in 1776 when Adam Smith wrote The Wealth of Nations. Now, when he wrote that book, the richest country in the world, which at the time was the Netherlands, was about 4 times richer than the poorest places in the world, which were at subsistence. So essentially, the Netherlands was at 4 times subsistence. Today, among the poorest countries in the world, you have Malawi. If you multiply by 4 the income per capita of Malawi, which was the difference between the Netherlands and the poorest countries in the world back then, you get to Haiti, which is by far the poorest country in the Americas. If you multiply by 4 the income per capita of Haiti, you get to Morocco. And if you multiply by 4 the income per capita of Morocco, you get to Poland or Argentina. And if you multiply by 4 the income per capita of Poland, you get to Singapore. So a problem that captured Adam Smith's imagination, which was a problem of 4 to 1, has become a problem of 256 to 1. And that's the puzzle of development. Now, we know some basic overall features of the story. Back when, in the year 0, incomes were very low, and for the subsequent 1800 years, they remained fairly flat throughout. But over the last 200 years, there's been something like a hockey stick of incomes per capita going up. And if we zoom into the hockey stick, we see something we like to call the Great Divergence, which is that something very dramatic happened in some parts of the world and not in others. And as a consequence, the gaps between the richest countries in the world and the poorest countries in the world now are orders of magnitude bigger than they were back when. That means that in the world today, it is possible to take this picture of people working in agriculture and to take this picture. Now, to take this picture of a harvester is not such a surprise, but to take this picture of a man working with a bull is really surprising, because if I asked you to take the picture of a typing machine, you would really have trouble finding a typing machine in a place other than a museum. Why? Because good technology displaces bad technology, and they go into the relics of history. So how come we can take in the world today at the same time a picture like this one and a picture like this one? And obviously, behind these 2 pictures are 2 radically different levels of productivity associated with 2 radically different levels of income. But that means that people are working very differently. Now, the traditional story of the gap between these 2 forms of production was that some parts of the world worked with more, say, land per capita, so there was more land available per capita, and maybe people put in more effort, and others were lazier. Maybe they had more capital, they had more access to machines and so on, and maybe they worked with more education. So the difference in those 2 pictures would supposedly be difference in something that economists like to call factor endowments. But economists have tried to make account of these humongous differences in income using these differences in factor endowments, and they came up short. So the puzzle of why some places are rich and other places are poor is because some places work with better productivity that makes the factors of production that they have just more effective. And as a consequence, they just produce more for whatever amount of factors that they have. Obviously, if those places are very productive, People will want to accumulate more factors of production, and that might even be part of the story. The reason why they have more factors of production is because it's a place where factors of production are very useful. So a dominant story these days is that differences in incomes per capita across places are due to differences in technology. Technology is a word we are going to define more precisely, but people are saying the difference in places are differences in technology, but some places have good institutions, and those good institutions lead to incentives to accumulate technology. And bad institutions lead to bad incentives to accumulate technology. And one way in which this was very beautifully put together is in the book by Daron Acemoglu and Jim Robinson called Why Nations Fail, right? And that book starts with the story of the two Nogales, Nogales, Arizona, and Nogales, Sonora, Mexico. And you would say, why, one place is richer than the other, there's just a border in between. What could possibly the difference be? It must be institutions. However, what the book didn't go into is that if you go into Mexico, you might go to a place like Guerrero, the state of Guerrero, which has a productivity per worker similar to that of, say, Guatemala or even worse, Honduras. If you multiply by 2 the productivity of the state of Guerrero, you get to the state of Sinaloa, which has a productivity, say, like that of Jamaica. If you multiply by 2 the productivity of Sinaloa, you get to the state of Guanajuato, which has a productivity like that of, say, Malaysia. And if you multiply by 2 the productivity per worker of the state of Guanajuato, you get to the state of Nuevo León, which has a productivity more or less in line with that of Korea. So within Mexico, you have productivity gaps that dwarf the gaps between Nogales, Arizona and Nogales, Sonora. And they are happening within the same legal framework, within the same federal judicial system, within the same political representation system, with the same exchange rate, with the same interest rate, with the same macroeconomic setup, with the same financial architecture. So we can, refine what we want to call institutions, but whatever those national institutions are compatible with the coexistence of a Honduras and a Korea within the same political framework. So we're going to go in a different direction in explaining differences in incomes per capita between places. We're going to say, yes, it is productivity. It is technology that is behind that productivity. However, technology is a word that should have been defined by diplomats, because the business of diplomats is to find words that hide disagreement so that everybody signs the communique. So this is not going to be useful for us here. By the way, the word institutions is also great for diplomats because nobody knows exactly what they mean by the word institution. So you don't know if you say, well, the difference is obviously institutions, you don't know what precise institutions are they talking about. But I'm going to say, yes, no, the difference is technology, but let's make a very precise definition of what technology is. Technology really is a little bit like the Christian God. It is 3 and it is 1. It is one that comes in 3 forms, but 3 very different forms, 3 different, what we might call ontologies. Technology comes in the form of tools. In that sense, you might say that tools are embodied knowledge. That is, that the knowledge that went into making the tool is in the tool. All the processes and stuff that went into making the tool is in the tool. Now the tool, you can just use it. You just have to know where the on button is and so on. You just use the tool. You don't need to know how to make the tool to use the tool. All that knowledge is embedded in the tool. So technology is tools, and that's why sometimes we call about the technology industry, and we refer to things like Apple and stuff like that. The second thing that technology is codes, recipes, formulas, how to do manuals. It is a set of instructions on how to get things done. In that sense, it exists in some symbolic space. In this picture here, it exists as ink over paper, but it's not the ink and it's not the paper that makes the stuff. In fact, here there is a picture of the ink on the paper, and it doesn't change the meaning of the code, because this code really exists in some symbolic space. And that's where this technology lives. While tools live in this three-dimensional world we live in, codes live in some symbolic space. Now, if that is all that technology was, and we would argue that the difference between places is a difference in technology, that would be a very simple problem to solve, because tools can be put on containers and shipped around the world, and we can send the container to Malawi. Codes can be put on the web and made available to anybody, so that get an internet connection in Malawi, you get all the codes, we'll ship you the tools, and game over. The problem of development has disappeared. But we know that there's something missing, and I said that technology is really three things: tools or embodied knowledge, codes, or if you want, codified knowledge. And the last one is something that we can figure out what it is by answering the question, what do you do when your tooth hurts? Well, you know, in a parallel universe, you might have said to your significant other, why don't you download an article from the web and fix the problem for me? But you don't do that for good reason. And what you do is you go to an expert. And that expert uses tools. That expert follows protocols. But that expert mixes the tools and the protocols with something you and I don't have, which is the ability to see into the mouth or look into an X-ray and see things that you and I don't know how to identify. And then to take those tools and move them with our hands in ways that you and I don't know how to do. That third thing that mixes with the tools and the protocols that the dentist is following is something we call know-how. Know-how is also known as tacit knowledge. So in the sense, the three forms of knowledge were embodied knowledge in tools, codified knowledge in codes, recipes, formulas, and tacit knowledge in brains. And I would like to say tacit knowledge in brains and not in minds, because tacit knowledge is a very, very odd substance. Tacit knowledge or know-how does not involve understanding. This is a very important idea, that know-how is just an ability to perform a task. For example, this guy here, he knows how to play tennis. He knows how to answer a serve. And the ball is coming at super high speed. He doesn't really have time to think, but before the other guy has even served the ball, he has an idea where the ball is going to go, what spin it's going to have, how it's going to bounce, and how to return it. But it's not his mind as this conscious self that has these things, because the game is going too quickly. It's his brain. His brain has been wired. He's been seen enough of these situations in the past that it can anticipate and predict what's going to happen. That thing is in the brain and not in the mind. In the same sense as I might tell you that Do you know how to walk? Tell me, do you know how to walk? You're going to tell me, obviously I know how to walk. Aha, so you know how to walk. So tell me, what muscles do you move when you walk? In what order do you move those muscles? Tell me, how do you keep your balance? Tell me, how do you regulate your heartbeat and your breathing so that you maintain adequate oxygen levels as you walk? Suddenly you realize that all of those things are happening and your brain is doing it for you, but they're not in your mind, they're not in your conscious self. Know-how is there. And that's why you don't teach your children how to walk by explaining the concepts to them. And by the same token, talking to Rafa Nadal about tennis does not improve your tennis game. That's not how you improve your tennis game. So know-how is something that is deep in the brain and gets there through a long period of imitation, repetition, imitation, until the brain kind of wires itself and gets it. And that's why Malcolm Gladwell says that it takes 13,000 hours to become good at something. So know-how is the third part, if you want, of the knowledge necessary to do things in the world. To do things in the world, you need tools, you need to follow protocols, codes, knowledge, codified knowledge that is out there, but you also need the know-how. And the problem in the world is that the know-how you need is not just individual know-how, it is team know-how. Now, you might say that this gentleman here knows how to fly a plane. But that would be a very poor description of reality. In order to fly this plane, that is, in order to implement this technology, you would need all these other people. Because all these other people are necessary to be working together to make this plane fly. So I'm going to say that the fundamental difference between rich countries and poor countries is going to be in the amount of know-how that has diffused in their society. Now, you might want to think and say, well, that means that this guy thinks that rich countries are full of geniuses that know a lot, and poor countries are full of idiots that don't know anything. And I'm going to disabuse you of that idea. But we're going to learn something in the process. So to explain that concept, I'm going to compare two hypothetical individuals. One is this Inuit from northern Canada, who in this picture is engaged in food production. Here is the same Inuit engaged in housing construction. And here is the Inuit engaged in the transportation industry. And I'm going to compare the Inuit to modern man. And I'm going to ask the question, who has more know-how? And you immediately realize that there's something wrong about that question, to the extent that questions can be wrong, not answers. But anyway, what's odd about this question is that this guy here, this modern man, he uses glasses, he uses headphones, he uses shirts, he uses watches, he uses computers, he uses screens. He doesn't know how to make any of that. If you bring this modern man back to northern Canada, one thing is for sure, he will die. We don't know if he will starve to death or he will freeze to death, but he will not survive in that environment. So it does not make any practical sense to say whether this guy has more know-how than the other guy. Now, it does make sense to say that the society to which this guy belongs has more know-how than the society to which this guy belongs. Because the society to which this guy belongs knows how to make glasses, headphones, shirts, watches, computers, screens, and so on. The society to which this guy belongs is a society in which everybody knows how to hunt, everybody knows how to fish, everybody knows how to make an igloo, everybody knows how to run a dog sled. So everybody in the society has more or less a complete copy of the technology in their heads. But in modern society, each one of us knows an infinitesimal fraction of what is known in society. And this is where sort of like the important message of the story is a society knows more, not because individuals know more, but because individuals know different. A society knows more, not because individuals know more, but because individuals know different. That if everybody in society knows about something else, the whole knows more than the individual. So it's societal know-how, collective know-how, that is going to be different between this modern society and the Inuits. The Inuits know how to do few things, but everybody sort of knows how to make them. There's very little division of know-how in the society. There's a much more advanced division of know-how in our society, so that the whole can have a scope of a much larger set of things that are known by the collective as a whole. So you might want to say, okay, so there's more know-how. Where do you put the know-how? So it's interesting to look at my employer, Harvard University. It was created in 1636 in this building here. And 1636 was, before Descartes, before Spinoza, before Locke, before Hume, before Newton and physics and Leibniz and physics, and before Lavoisier and chemistry, before Linnaeus and anatomy, and before Darwin, before Einstein, before Faraday, before everybody. So there was a much smaller scope of knowledge in 1636 than we have today, and as a consequence, we needed more buildings to put those knowledgeable people, and more buildings to put them, and more buildings. Now, in 1636, a college degree lasted 4 years. Now, we have so much more to teach. How long would you guess a college degree lasts now? Well, fortunately, it's still 4 years. But how did the system adapt to the fact that there's so much more to teach and only 4 years to teach it in? And the answer is obviously specialization. We've created many more majors, many more degrees, and these only count the ones at Harvard, not counting all the ones at MIT, which complement this list enormously. So this makes the point that while you can store more books in bigger libraries, the only way you can store more knowledge is by putting different bits of knowledge in different heads. So now we've put different bits of knowledge in different heads. How can we use that knowledge to make things? Well, let's look at things from the point of view now of products, of things you would want to do by deploying technology. Well, products will need to use know-how. Well, but know-how doesn't fit in the same head because it takes, as Malcolm Gladwell says, 10,000 hours to become good at something. And 10,000 hours, by the way, at 40 hours a week is 13 years. So that's one of the reasons why your dentist tends not to be your lawyer. So we are going to ask ourselves the following question. If there is this societal knowledge that is so big, how do we split it up in different brains? How much do we put in each brain? Do we put 1 kilobyte of knowledge, 1 terabyte of knowledge, 1 gigabyte? Well, we don't know what that unit is, but it's some unit like that. We're going to call it a person byte. So a person byte is sort of like the amount of know-how that kind of comfortably fits in the head. So that there's like a person byte of a dentist and so on, a person byte of a lawyer, but a dentist plus a lawyer doesn't fit, because if it takes 13 years to become a good lawyer and 13 years to become a good dentist, by that time you forgot law. So these things cannot be expanded forever. So I want to introduce the idea of the person byte. Now I want to ask myself a question. If I want to make a product, how much know-how do I need to mobilize? In this language, how many person bytes do I need to mobilize? So if a product requires more than 1 person byte, it cannot be done by 1 person. So now we need to bring people together. And we bring people together in things we call firms. And because firms are not enough, we need to bring firms together in networks of firms we call value chains. So one way to now think of the economy as this know-how processing machine is to look at the outcome of something and ask yourself the question, what is a social network I need to bring together to make this? And here you have a picture of a subsistence farming family in Ecuador. And that family knows how to make the products in this picture. Now, if you look at this picture here, there is no family that knows how to make these cameras and other electronics. They're just too complex. There's just too much know-how that does not fit comfortably in a family. They have to be done in much larger organizations. And if you look at this picture here, this is the Boeing 787. It is supposedly made by Boeing, but you see the Boeing is this purple fuchsia color in this picture, and Boeing makes less than 15% of the parts that go into the Boeing 787. They assemble it, but they assemble it by adding all of this know-how that went into making millions, literally millions of parts that make the airplane. And that's a set of companies throughout the world that have to cooperate, not because they're going to make many airplanes. All of them have to be there just to make one airplane. Because the know-how of turbines and the know-how of landing gear and the know-how of avionics and so on, those are very, very different sets of the knowledge space that have to be coordinated, but they have to be brought together in the making of the airplane. Now, this does not mean that companies need to be large. Here you have a picture of a large company. But one thing that you see in this picture is that probably everybody there is using the same kind of person byte. This actually is a chicken processing plant in China. And you can imagine that if you just flip around the different workers in the plant, nothing much will happen to the production process. But if you take a look at this picture, if you flip around the people in the picture, you will hear the difference. Because each one is bringing kind of a different person byte to the story. So the size is not the metric that we want to emphasize. yes, products that require many person bytes are going to require a social network that brings together many different people, maybe not necessarily in the same firm. But complex things are things that mobilize a lot of know-how, and that know-how imply bringing people together that know about different things, whether it's the oboe, the viola, the timpani, the cellos, and so on.